Welcome back to First Take Math with Brian. Getting a little more less informal now. Been with you now, pushing to the last part of our last chapter here, our chapter 2. We are wanting to, again, work on solving quadratic equations, and again, one of our key strategies is going to be setting the equation equal to 0. And remember, a quadratic equation has this, what they call the quadratic term. It has this x squared term in it. Then it's got this linear term, and then this constant term. The strategy we want to use today is we want to solve a quadratic equation by factoring. Let me fix this one real quick here. It's not an equation until we set it equal to something. I'm going to go ahead and set it equal to 0. So remember, an equation has to have a left side and a right side. Otherwise, there's nothing to solve. So when we see something like this, one of the strategies we can look for is factoring. And remember, since there's not a complicated number in front of x squared, we can pretty much just go straight to mama. Okay? So mama says we need this 15 and this 8. We have to ask ourselves, what can you multiply to get a 15? Well, we know that 1 times 15 is 15. 2 doesn't work, but 3 times 5 does work. Also, 3 plus 5 does give me my 8. So there's my winner. So the mama strategy allows me to factor this into then. Set it equal to 0. So my variable is x, so it's going to be x plus 3 and x plus 5. And remember, these were the edges of the rectangle. So if I kind of squeeze this in here, this was not necessarily work anymore. We knew that we can break this apart into 4 pieces. So we have our x and 3 goes here, our x and 5 goes here, x squared, 5x, 3x, and 15. And you should see there is my 8x, so that is the correct factorization. But again, that's no longer really necessary with our strategy. That's just more a way of verifying it. So mama really just takes care of it. So I can get that out of there if I want. So once we get it here, we're just going to ask ourselves, what can you multiply by to get 0? Well, if this is 0, then this is going to work. Negative 3 would make that 0. If this is 0, then it would work. Negative 5 would make that 0. So negative 3 or negative 5 would be my solutions. Now, if you can't see that, we can just set each factor equal to 0. So x plus 3 is equal to 0. Or x plus 5 could equal 0. And then we can 0 out with a negative 3. X equals then a negative 3. We can 0 out the 5 with a negative 5. And x is going to equal then, and 0 and a negative 5 does give me a negative 5. So our solution does become the negative 5 and the negative 3. That's my solution set. So if I substitute those numbers in to this equation, both of them won't work. So it's kind of interesting that the power of 2 actually has 2 solutions, where a linear equation only had 1 solution, typically. So let's look at this equation, a little bit different. Notice how it's not equal to 0. Our first objective is to set it equal to 0. So 14's got to get zeroed out. So I need to put a negative 14 here to get rid of it. But I got to balance the equation, so I got to subtract 14 on both sides. So we're going to create a new equation. This new equation is going to be x squared plus 5x minus 24, and that is now going to equal our 0. Now we're ready to focus on our mama. The negative 24 is my multiplication piece. The adding piece is that 5. So to get a 24, we know 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. 5 doesn't work, 6 is there. But now we got to focus on that that's negative 24. So one of these has got to be negative. But which one? That's where the 5 comes in. Notice how the 5 is positive. That means the bigger number's got to be positive. So this side's got to turn over to be negatives. Now we actually see that negative 3 plus 8 is going to give me my 5. So that's the winner. That's the one that's going to pass the Monmouth test. So I'm going to be multiplying and adding to verify that. So that negative 24 comes from the end, the 5 is on the middle term, and that creates our Monmouth. So now this tells me how to factor it. So using our parentheses, we write our factorization, and we have x minus 3 and an x plus 8. And we have to set each factor equal to 0, or what makes that 0 will be a 3. What makes that 0 will be a negative 8. So 3 and negative 8 would be the solutions. Again, if you can't see that, just set x minus 3 equal to 0. Also set the x plus 8 equal to 0, and solve each equation for x. The negative 3 can be zeroed out with a positive 3. So you're going to get x equals 3 here. The positive 8 can be zeroed out with a negative 8. So I'm going to get x equals a negative 8 as the solution. So again, your solution set would be then a negative 8 or a positive 3. So we'll look at a few more examples, but that's getting us into there. Stay tuned for a few